Okay, so first off, let's take a look at the far right one. And what I'm going to do is I'm going to have you take a look at looking at the labels, where the labels are. So there's labels up top. There are not labels here. Everyone see that? That means it cannot be a matrix. A matrix must have labels across the top and along the side. If it only has one or the other, it cannot be a matrix. Everybody on board with that? So this cannot be a matrix. So instead what I have are two lists. Does everyone kind of see that? So it can't be ANOVA because there's only two lists. ANOVA has to be 3 or more lists. So this one is what?
Linear regression.
Yeah, linear regression.
And it also has the X and Y.
Yeah.
Giveaway.
Linear regression, chapter 10. And again, age and wealth. So that's the other thing. Are age and wealth 2 different categories of the same variable? What would be the question? No, they're 2 different variables.
Yeah.
Right? They're not 2 different answers to the same variable. Good. And then how about the next one, the one next to it? So here next to it, we have categories here. We do not have categories there. So it cannot be a matrix again. So here we have 3 lists. So this one's what? ANOVA. We have 3 or more lists. That's ANOVA.
What does ANOVA stand for?
Analysis of variance. AN, analysis of, O, and then variance, VA. And then the one below it, let's see, where are my categories here? I have categories here, categories there. So this looks like it might be a matrix, but now I need to confirm that these are actually categories. So football, baseball, hockey, are those different categories of the same variable? Yes. Sport, right? How about here, male, female? Are those different categories of the same variable?
Yes.
Yes. Gender, everybody good? So this one is, I know, this is clearly an old problem since it doesn't have non-binary in there, right? So what kind of problem is this one? Yep, chi-squared matrix.
No.
Everybody all right with that part?
Yeah.
11.2. And then let's look at the last one. For the last one, there are categories here and categories there. So we might think chi-squared matrix. Let's confirm. Are these different categories of the same variable? Yes. How about here? Are these different categories of the same variable? No. These are observed and expected. So really, it's just one row, right? Those are my observeds. These are my expected. So it's like a whole different group. For the chi-squared, I have a matrix. That's my expected, and then my observed, and then I'd have a whole nother matrix of my expecteds, which you'd have to compute. Here we have the observed, which are given, and then this is just another line of the expecteds. So really, it's just this one kind of group of frequencies for each possible category. So this one ends up being what? Yep, GOF test. 11.1. Okay, all right. So we're going to try looking at these. So there's the visual way. There's the variable what we talked about before, and then there's also some verbal cues which we'll see as we kind of go through this. So first things first. All right, go ahead and read the first problem. That's cesarean in case you weren't sure. Go ahead.
What kind of problem is this? Hospitals and cesarean delivery rates. The national cesarean delivery rate for a recent year was 32.2%. Number of live births performed by cesarean section. A random sample of 100 birth records from the 3 large hospitals showed the following results for the type of birth. Test for homogeneity. Homogeneity of proportions using alpha is 0.1.
Great. All right, so on your own for 15 seconds, try to figure out what kind of problem it is. 15 seconds, go. No talking on your own. What kind of problem is it? Again, you can think of it visually. You can think of the types of variables you're involved in or the cues. Okay, talk to your neighbors about it.
Is it homogeneity proportion?
Yeah.
That's the giveaway right there.
All right, so visually, we've got this and we've got that. Are those different categories? Are these different categories? No? Cesarean and non-cesarean? Are those two answers to a question?
Yes.
Yep, so those are categories as well. So this is a chi-squared matrix. Everybody okay with that part? There are also cues. For example, homogeneity of proportions. That's a chi-squared matrix test. Okay? The second thing you can ask yourself is, what do I know about each person that was surveyed? I know two things about them. I know what? What's one thing I know about them? What hospital they're in? What's the other thing I know about them? Yeah, whether or not they had a cesarean birth. So those two things, the answers to that are going to be categories. So this is going to be two category variables. So this is going to be, again, a chi-squared matrix. Right? As Owen starts saying, two variables that are categories. Okay, we'll take a look at another one. Alexa, go ahead and read.
Auction bids. The author is a member of the board of directors of a nonprofit organization that held a fundraising auction. He recorded the opening bid suggested by the auctioneer and the final winning bids for several items. The amounts are listed below. Is there sufficient evidence to conclude that there is a linear correlation between the opening bid suggested by the auctioneer and the final winning bids?
Great. 15 seconds on your own. Try to do it independently if you can. Okay, check with your neighbors.
Lynn read.
There's no
It also said linear correlation.
and there's no name on the column.
Yes.
Chapter 10.
They just give away linear.
Okay, so visually I have this and known labels there. So what else is going on?
It also says linear.
It says linear correlation, exactly. So this is what?
Lynn read.
Linear regression.
Is it also because there's only two?
Yep. You have two lists, right? It's not a matrix because there's nothing up there, so it cannot be chi-squared matrix. You have two lists, not three lists, not three or more lists. So this is linear regression. Okay, I'll give people 15 seconds to read this one on their own. So to yourselves, on your own, read it. Okay, check in with your neighbors.
Matrix.
All right, so are these, we have two things on the front, the top and the side. So I'm thinking matrix, but let's just check to see if these are actually variables. Are these different answers to a question? Yes? What kind of drug were you given? Are these just different answers to a question? Yes? Did you have an infection or not? So that looks like a chi-squared matrix. And then let's see if there's other sorts of things. Independent. Test of independence. Totally a chi-squared matrix. Then also you can confirm that you know two things about them. What drug they took, whether they had infection. Those are both categories. Okay, I'll give you folks 20 seconds on your own to take a look at this one. All right, check in with your neighbor. All right, so there is nothing visually at all. There's no table. There's no table. All there is one list. This has to be a what? Yeah, goodness of fit test, right? 11.1. And also they're talking about equally likely and frequencies. Once you have frequencies, frequencies means it has to be one of the chi-squareds. So since it's not a matrix, it must be a chi-squared list. Because frequencies, proportions, those are all chi-squareds. Those are categories. All right. 20 seconds on your own. 15 seconds.
Is that the one where you have to change it? 'Cause I can't find your zone you change to the 84.
Yes. Okay, check it with your neighbors.
It's like just matrix.
Anova.
But there's no label.
It is Anova. Clancy, Rowling, Velocity.
Huh?
No, see the Clancy, Rowling, and
Yeah,
the.
but there's no top label though.
Those are the labels. It's just sideways.
Yeah, they could be sideways.
I thought it's supposed to be both ways.
Okay, I have something here, I have nothing there. So it cannot be a matrix, right? Because a matrix has to have the top and the side, so it's not a matrix. Instead I have 3 lists. 3 lists is what?
Anova.
Anova.
ANOVA. Also they talk about means. ANOVA is the only one that's going to talk about means. You're comparing means.
So it's 3 or more.
3 or more. 3 or more means. If you only have 2 means, then you just use a 2-sample t-test. ANOVA is for 3 or more means. All right, I'll give you folks 15 seconds on your own for this one. Want me to do that? All right, go ahead and check in with your neighbors.
Anova, yeah. There's 3 more words. And it says it.
All right, because on the exam, I am not going to tell you what section you're looking at. I will do this. I will group all of exam 4 material together, but within exam 4 it'll be all mixed up, which is why we're going over this. You can tell the difference between which problem it is on exam 4. And then I'll have exam 1 grouped together, and then exam 2 grouped together, and exam 3 grouped together, and then exam 4, or it might be the reverse. Exam 4, then 3, then 2, then 1. But within the exam, it'll be all mixed up. Okay, so let's take a look at this one. We have, okay, so my first thought is this. That's my first thought. So then that would make it 3 lists, so then that would be ANOVA. So let's see, are these 3 different lists of the same thing? Games played, actual word series contests, expected proportions. Those are not 3 different groups of the same variable. So it cannot be, that must have been incorrect. So not that. So then, okay, well maybe it's this and then there's that. Maybe like that.
No.
Right, so that'd be a matrix. So are these different categories? Games played, yeah, it could be 4, 5, or 6 or 7 games played, so that's fine. But are these 2 different variables at actual word series contests and expected proportions?
It's not.
What was that?
Stop.
What's,
Goodness of fit.
what was that?
Goodness of fitness test.
Yeah, so what's up with the actual and the expected?
It's called actual World Series contestant. That's the expected, and then the expected proportions. Like
These are my observed and my expected.
Yeah.
Does that make sense?
They're just disguised in fancy vocabulary.
Exactly. So these are my observed values and my expected ones, which I'm going to have to calculate. So this is a, anyone?
Goth.
Yep, goodness of fit test. And we know it's also proportions, right? So the actual fits the expected, fits, right? So that's also tells me it has to be a chi-squared.
Are you going to trick us like that on a test?
I don't think so. But still, it's good to have, to kind of be able to identify these.
Yeah.
If you can do this, then you can definitely do the exam. All right, how about this one? I'll give you folks 10 seconds on your own. Check in with your neighbors.
Matrix.
Alright.
ABC and total.
I'm sure they have chi-squared golf test, right?
I don't think it's called.
It's this one.
It's just chi-squared test.
It's this one, right? Is that matrix? Is that matrix? Oh, it is.
All right, so we have stuff here. We have stuff here. Are those categories? Yes?
Oh, yeah.
Are these also categories? Yes, so this is what?
The golf test for matrix.
Chi-squared
For golf.
matrix.
Yeah.
So remember, a matrix is this set of numbers it's got rows and columns in it. That's how you know it's a matrix. That's kind of your cue that it's a matrix. Also, there should be something about relationship. So relationship, that's a chi-squared matrix. That's 11.2 chi-squared type of test, right? Relationship, independent. Okay, just a few more. I'll give you folks 2 seconds for this one. Check with your neighbors.
Right. Yeah. It's a correlation and then those two categories.
Okay, so what do you think? There's stuff here, there's nothing there, so it cannot be a matrix because I don't have things in both spots. So I have two lists. Two lists is what?
Linear.
Yep, linear regression.
And it also says linear correlation once again.
And yep, and then it also says linear correlation. Good? Okay.
Oh, yeah, for that. Yeah.
All right, so I'll give you folks 10 seconds for this one. Check with your neighbors. Okay, which one is it? ANOVA. You have stuff here, you do not have stuff there. It is 4 lists.
Also has mean.
ANOVA, and then yep, it also says there's that verbal cue mean. Everybody on board with this? Okay. Is it getting easier? Okay, great. Take a few seconds for this one. Check with your neighbors. Okay, so there is nothing here. Does anyone see there's nothing there? So that cannot be a matrix, because the matrix, I have to give you the stuff. It cannot be any of the 2 or more lists. It cannot be linear regression because it doesn't have 2 lists. It cannot be the ANOVA because it doesn't have 3 or more lists. The only thing it can be is there's one tiny little list here. This is goodness of fit. 11.2. Yes.
What if they made like a table? Then would it be like they brought all that out of the table?
And they put that all into a table, then we can talk about it. But then it would still be just one set of labels and one set of numbers. Does that sort of make sense?
Oh yeah.
So then it would only be one list. Does that kind of make sense for folks?
So basically on the test, if we don't, if it's about this and we don't see a table, then we should know it's gone.
Then it's off.
Yeah, so when they give us that, we have to find the expected, right?
Right.
Okay.
So if it was like this,
Yeah.
then you'd have to recognize that these are not, that this is, and it says proportions, right? So these are your labels, and then these would be your expected. And actually, you'd have sort of a blank here with expecteds where you have to compute them. So that's kind of the way of telling. All right, we got one more. I'll give you 20 seconds on that one. Here, should I talk about this more? So you have to compute the expecteds. So I'll give you the categories, I'll give you the observeds, and you have to figure out what the expecteds are. So everybody kind of following that? Yes? And I'll call it observed, I won't call it actual. I'll use the word observed. Okay. All right, so this one, 5 seconds. Check in with your neighbors.
X and Y.
All right, what kind of problem is it?
Lagrange.
Yeah, there's labels here. There are not labels there.
Also X and Y.
So it's two. And there's also an X and Y. So there are two lists, And then relationship or correlation is also, I know it's chi-squared, it's a chi-squared matrix, and it's also linear regression. It's both symbol spots. So you might see that either way. But because it's not a matrix, then that means it's linear regression.
They also give us X and Y.
What was that?
They also give us X and Y.
Yep, and X and Y. That's another good way of telling it. All right, so this is lab problem 6 that we did not do from chapter 10, which I said we're going to do today. So go ahead and work on it now.